Okay, so we continue here with our series on properties of transition elements, and we are going to talk about redox titrations. We have a slightly more complex problem here, and so we want to look at how you can go about such a problem. So we're going to work out here the percentage of iron in iron tablets. So let's look at a question that says here, calculate the percentage of iron in a tablet with a mass of 2.50 grams, which was dissolved in dilute sulfuric acid to give a 250 cubic centimeter solution. A 25 cubic centimeter portion of the solution reacted with 12.5 cubic centimeters of a 0.025 moles per cubic decimeter potassium manganate solution. So a titration was carried out here with a portion of the 250 cubic centimeters, which was made by dissolving a 2.5 gram tablet. So it's important here for you to understand why is it that we take a portion which is 25 cubic centimeters and carry out a titration. This is because 250 cubic centimeters, we can carry out a titration with the exact 250 cubic centimeters and figure out how much potassium manganate is needed. But this would require a very huge burette, a very huge conical flask, which is not feasible, which is not practical. So it's a practical trick. We take a portion. So later on, we have to remember that we have taken a portion of the total number of moles of the iron that were there in the 250 cubic centimeters. Let's move on. So the first thing is always to write a balance equation for the reaction. So as before, if you look into our previous video, you realize that we looked at this equation before. You have to combine the two half equations, your oxidizing agent, which is your manganate ions, and your reducing agent, which is your iron. So the titration that was done with the 25 cubic centimeters there is a redox titration, which involves an oxidizing agent and a reducing agent. Okay, the second thing is to figure out from the information that you're given, is there information that allows me to calculate the number of moles? So which reagent am I able to calculate the number of moles? So if you look at that information, you can calculate the number of moles of the potassium manganate that you were given. So if you look at that information, number of moles is equal to concentration times the volume. Your concentration is given there, which is 0.0250 times our volume converted to cubic decimeters, which is equal to 12.5 times 10 to the power minus 3. The next thing that you're supposed to do is use the equation to find the molar ratio in order to work out the number of moles of iron. So if you look, we have a 1:5 ratio. For every 1 mole of manganate ions, we require 5 moles of iron. So since we have the number of moles of manganate iron, we can simply multiply this number by 5 to get the number of moles of iron. So 1:5, and we get our 1.565 times 10 to the power minus 3 moles. So that is the number of moles that are available in 25 cubic centimeters. Now what we have to do is calculate the number of moles that were there in the 250 cubic centimeter portion. Remember, we took a 25 cubic centimeter portion. Now we need to figure out the total number of moles that were there in the whole 250. So we took just 25 cubic centimeters out of 250. So we took 1/10. So for us to figure out the number of moles that were in the 250, we have to multiply by 10. So that is what gets us to 1.5625 times 10 to the power minus 3 times 10. So in the 250 cubic centimeters, there was 1.5625 times 10 to the power 2. Now that we have the number of moles that were in the 250, so these are the moles that came from dissolving our tablet, which had a mass of 2.50 grams. So for us to calculate the mass that was in the 2.5 gram of the tablet, we now say the number of moles times the relative atomic mass of our iron. So this will give us 0.871 grams of iron. So the tablet contained 0.871 grams of iron. Now, when it comes to the percentage of iron that was in the tablet, we now need to say our 0.871 gram divided by the total mass of the tablet. So this is the last stage where you divide the mass of the iron over the total mass of the tablet and multiply by 100. So this will give you 34.8%. So you need to follow this sequence, this logic, when you are solving redox titration problems. I would want you to do me a favor and like and subscribe, and also share this video with a friend. I'll meet you in the next video.